Welcome to 4.2 Venn diagrams and multiplication rules. So first we are going to reintroduce Venn diagrams. They are something you have seen previously. I have a Venn diagram is a display of potential probabilities. Remember that the entire box around a Venn diagram is going to represent the total sample space, and it has to add up to 1 or 100%. And the circles themselves represent the probability of each event. So first I have probability of event A. That is represented by the entire circle A. Probability of event B is represented by the entire circle B. Now, when I want the probability of A and B, I am interested in where they occur together. So this overlap section right here is going to be A and B. Now, in statistics, it is very important that you do have this box around it because we're not only considering the probabilities of events A and B, we're considering the probability that neither of these occur. So we'll always have a sample space around our two event circles. Now, some vocabulary that we have to go over because it will be very important for the AP exam: union and intersection. So anytime we have the statement or, it's going to be a union represented here by this little U, and it's going to be the probability that either or occurs. And is going to be represented by the intersection, and it looks like this little N symbol here, and this is the probability that both occur at the same time. So this is one or the other. This is both occurring at the same time. So if I want to shade in my area for the probability of event A, it's going to be the entire circle A. If I wanted to shade in the probability of A or B, it's going to be the entire circle of A as well as the entire circle of B, because remember, it's either or, so it could be both of them at the same time when I'm doing or. Now, A and B is very specific. It's only the overlapped region of the two circles. And then if I want A complement, I have to remember that it's everything outside of the circle A. So it's not only this shaded region of B, but it's also the outside box of S. Let's see if we can shade everything in one go without it freaking out on me. There we go. So it's literally everything outside of the event A circle. Now, some examples that we're going to go over: the probability of A and B complement. So remember, B complement means that I'm doing not B. So this is going to be where A occurs and not B occurs. So this time, I'm interested only in where A is happening, but no event B is happening. So just this portion of my event A circle. For my second example, I have the probability of A complement, so not A or B. So where not A occurs or B occurs. So not A, remember we did it over here, is everything outside. And we want to know or B, so basically I'm going to shade the same area as I did up above. Everything that is not A. And sometimes there is multiple ways to describe the same shaded region, just like I have here. Both of these things are the same. And then I have the probability of not A and not B. And remember, this is why it's important for us to include the box around our Venn diagram, because this shaded region is just the sample space outside of the Venn diagram. I'm going to shade everything outside of my two circles. So let's get started on a word problem. A study was done as to whether parents who were spanked as children are more or less likely to spank their own children. They interviewed 200 parents anonymously, and it was found that 125 were spanked as children, 92 spank their children, and 74 are in both categories. So we're going to create a Venn diagram and answer some probability questions. First thing I'm going to do with my Venn diagram is I'm going to label both events. So I'm going to call event A, a parent was spanked, and event B, a child is spanked. Now I'm going to take my given information that I have and I'm going to organize it. So I know that A is equivalent to 125, B is 92, and A and B is 74, meaning they're in both categories. And this is going to be the first number that we place. The overlap, you always want to place first. So I placed 74 right in the middle of my Venn diagram. And then now that we know 74 is in the middle, we can kind of work backwards from there. So I know 74 is in the middle. So if I want to get the value of A by itself, A but not B, all I have to do is take 125 minus 74, and that tells me there's 51 people in this portion of event A. I'm going to do a similar thing for event B. B but not A is going to be 92 minus 74, which is 18. And do not forget that this is not the only people in my survey. I have to think of everyone who doesn't fit into these two categories. So not in either is going to be my entire survey of 200 adults or parents minus 51 plus 74 plus 18, which is going to give me 57 in just my sample space, not in a Venn diagram circle. So now we're going to go ahead and answer some probability questions about my Venn diagram. So what is the probability that a parent was spanked and they spank now? So A and B. So I want the probability of A and B. Remember, it's very important that you have a probability statement. So if I want A and B, all I have to do is look at my overlap of the two Venn diagrams. That's 74 over 200, which is 0.37 as my final answer. What's the probability that a parent was spanked or they spank now? There we go. So A or B. Probability of A or B is going to be, there's two ways we can approach this. First, we can do it using the general addition rule, probability of A plus probability of B minus probability of A and B, which is going to just be 125 over 200 plus 92 over 200 minus 74 over 200, which gives me my 0.715. Now, oftentimes, if they do not ask you to make a Venn diagram, you won't. But if you do, you could approach this in a much quicker way. If I just want the or statement, all I have to do is look at my Venn diagram. If I just want A or B, remember it's both circles entirely. So I add 51 plus 74 plus 18, which gives me the same value of 0.715. Either method works, either method is valid. So let's go ahead and look at C, probability that a parent was spanked, but, which we're going to consider as an and for now, doesn't spank now because we want both of these things to happen. So I'm going to have the probability of A and B complement because they do not spank now. So now I'm going to go ahead and look at my Venn diagram because I want A, but I don't want B in it at all. So I'm going to ignore this overlapped section and only use my count of 51. So I'm going to get 51 over 200, which is 0.255. And for D, what is the probability that a parent wasn't spanked, but so A complement, but, and we're considering this as an and for now, does spank now. So A complement and B. So A complement and B. So remember, A complement is everything outside of circle A, but I also want to be in the B area. So the only section that meets that criteria is my 18. 18 over 200 is going to be 0.09. So it kind of just takes you looking at your Venn diagrams, seeing where everything fits, and finding your numbers that match. And we will kind of approach and in a different way in just a little bit, but for now, Venn diagram is the best method so far. Probability that a parent was neither spanked, so A complement nor, which we're going to consider to be an and, even though it sounds like an or, because it's neither nor do they spank now. So I want the probability that they were not spanked and they do not spanked. So I'm going to go to, so the probability that they were not spanked is everything outside of A, and the probability that they do not spank is everything outside of B, meaning they were not in either. So my count for this is 57. So 57 over 200, which is approximately 0.285. And this is a little tricky one because it's going to not necessarily be one probability statement, because we will, again, in a future lesson, approach a problem like this in a different way, but we can still answer it just using Venn diagrams. What is the probability that a parent was spanked, so A, or spanks now, but they do not do both? So I want A or B, but I don't want the overlap. So what's the probability of A or B minus the overlap A and B? So I'm going to look back up A or B, but I don't want this overlap of 74. So all I have to do is I could go in and just do my decimals that I've already found. I've done A or B to be 0.715, and I have done A and B to be 0.37, which gives me 0.345. But I also could approach it in terms of counts, or I could say that 51 plus 18, which was the A and the B without the overlap, divided by 200 is 0.345. Okay, let's go ahead and look at example 3. A pizza shop has two sizes of pizza, large and small. On a certain day, a pizza shop made 59 plain pizzas, 72 pizzas with toppings, and of the 59 plain pizzas, 19 were small. Of the 72 pizzas with toppings, 42 were large, and a pizza is chosen at random. We want to find some probabilities in just a second, but first we need to organize our information. First in a two-way table, then we will convert it to a Venn diagram. One piece of advice that I have here: anytime you are given data and you are told to organize it, you're going to want to go in and place everything that you are given first. And that's everything that I currently have highlighted here, and then work backwards using logic. So I'm going to go ahead and label my table. I have size up top, toppings on the side. You could flip this if you wanted, that's okay. And I'm going to place all of the information that I currently have. I have 19 small plain, and I have 59 plain pizzas total. I have 42 large with toppings and 72 pizzas with toppings total. And then I just kind of work my way backwards. So like 59 minus 19 is going to give me 40. 72 minus 42 is going to give me 30. And then from here, I can just add up my columns to get my totals in my row. Now that I have all of my information organized, I'm just going to place it onto my Venn diagram. One thing you have to be careful of is what you identify your two events as. Notice that I made event A a large pizza and event B a plain pizza. The reason why I did this is because these two things will have an overlap. if I were to make A large and B small, then I'm just going to have two circles in this sample space, and I'm not going to be able to really organize my data effectively. So we do know how many pizzas we have that are large with no toppings, so B complement. That's going to be my 42. That's coming from here, large and toppings. And we know how many we have that are large and plain. We said that that was 40. That's why that's my overlap. And we know how many are small and plain, which is 19. And then we know how many were small with toppings, which represents my outside sample space of 30. So basically all I did was take this 4 square piece of my table and put it into my Venn diagram based on how I labeled my events. Again, you could switch it up. You could make B plain and A large. I mean, yes, A plain and B large, but it's going to still result in the same probabilities. So I'm going to go through the first couple kind of quickly because they are very basic probabilities. So I have the probability of A because I want a probability of a large pizza. So all I have to do is take my total count from A, so 42 plus 40, which is 82 over 131, which is approximately 0.6260. And then I want the probability of a small pizza, and that's going to be represented by A complement, and that's just going to be everything outside of the circle A. So that's going to be this 19 and this 30 added together, 49 over 131, 0.3740. What is the probability that the pizza has toppings? And I said toppings was going to be B complement. So I'm going to go ahead and look everywhere outside of this circle B. So this 42 plus this 30, which is 72 over 131, which is approximately 0.5496. And what is the probability of a plain pizza, which I called event B? So all I have to do is take my 40 and my 19, add it together to get 59 over 131, which is 0.4504. So these were kind of just basic probabilities coming directly from the Venn diagram. Now we're going to get into some interesting things. So I have, what is the probability of a large plain pizza? So I want the probability of A and B. So all I have to go, I can either use the table or I could use my Venn diagram. I just want the intersection of event A, which is large, and event B, which is plain. I want them both to happen at the same time, and that count for us happens to be 40. So I'm going to have 40 over 131, which is approximately 0.3053. Then I'm going to go in and look at what's the probability of a small pizza with toppings. So the probability of A complement and of B complement. So let's remember, A complement is everything outside of the circle A. So we're talking everything in the sample space and this little shaded part of B. Well, B complement is everything outside of B and this little part of A. So now, if I want to be outside of both of these circles entirely, the only thing that fits is this 30 count of my small pizzas with toppings. So A complement and B complement is going to be 30 over 131, 0.2290. Let's go through and highlight my answers. Now for G, we want the probability of small or plain. So I'm going to have A complement or B. And remember, you can still approach this using the general addition rule. This is going to work. However, it's also very easy to go in and look at your actual table, your Venn diagram. So I'm going to go ahead and I'm looking at A complement or B. So again, A complement is everything outside of circle A. So that's 19 plus 30, which is 49. And then B is everything inside circle B. So 40 plus 19, which is going to be 59. And then A complement and B is just this count of 19. So all I'm going to do is take my values, 49 plus 59 minus 19, all over 131, which is okay because we're dividing by the same denominator, fraction rules. That gives me, I think I went straight to the decimal and I got 0.6794. For H, we are going to look at the probability of A, which is large, or with toppings, which is B complement. So I want the probability of A plus the probability of B complement minus the probability of A and B complement. So if I go up to my Venn diagram, the probability of A is 40 plus 42. The probability of B complement is going to be this, everything outside of circle B. So that's going to be 42 plus 30. And the probability of A and B complement is just this one sliver of event A. So 42 all by itself. So that's going to give me 82 plus 72 minus 42 all over 131, which is approximately 0.8550. And then for my last question, this one is easy, the easiest one you're going to come across. What's the probability of a small pizza or a large pizza? So probability of A complement or A. Well, you only had two options. You had small or large. And if I go in and I look, if I want A, that's the entire circle A. And if I want A complement, that's everything outside of circle A. So basically, I'm shading the whole Venn diagram, the whole sample space. So this is going to total out to be 1 or 100%. The last thing that we're going to cover to wrap up these notes is the multiplication rule. So we're going to say that you rolled a die two separate times. What is the probability you get an even number followed by a 5? So we want to get an even number first, then we want to get a 5 second. So there are two ways to accomplish this. The first way is going to be similar to what we did in 4.1, where we would list out our sample space. And in this instance, there's a possible 36 outcomes. And there are three instances where this occurs. If I were to roll a 2 first, then a 5, 4 first, then a 5, and a 6 first, then a 5, that gives me 3 out of 36. Now, there is technically an easier way because it may not always be as easy as dice, and you don't want to have to write out a really large sample space. Looking at the multiplication rule, my first roll, if I wanted an even number, I have a 3 out of 6 chance of that happening when I roll a die. For my second roll, if I want a 5, I have a 1 out of 6 chance of that happening. So in order to get the probability of both occurring, all I have to do is take 3 over 6, multiply it by 1 over 6, which is going to give me the same total that I had over here of 3 over 36. Now, writing this as a formal statement, I have the probability of A and B is equal to just the probability of A times the probability of event B. This, however, is only going to work if we have independent events that do not influence one another. So let's go ahead and look at example 4. You roll 2 dice, one red and one green. What's the probability that you roll a red 1 and a green 5? Well, if I want a red 1, that probability is 1 over 6. If I want a green 5, that probability is 1 over 6. So the overall probability is 1 over 36. For example 5, a coin is flipped and a die is rolled. What's the probability that the result is a heads and a 6? Well, my probability for a heads is 1 over 2. My probability for a 6 is 1 over 6. So if I multiply those two together, the probability of this happening is 1 over 12. What is the probability that a couple will have 4 boys in a row? So this is going to be more than one event, more than 2, I mean. So I'm going to have 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. Multiply all those together, the probability of having 4 boys in a row is 1 over 16.